Good morning and welcome to Workplace 30. We're looking at quadrilaterals today, and the first thing I want you to do with your sheet is pause this video and take a look through here. I'll give you as much time as you need to look through here to get familiar with these. Okay, I'm assuming you paused the video and you're a little bit familiar. Some of the words and stuff, terms here. Quadrilateral is a closed four-sided figure that lies on a single plane. This example here is misleading. A quadrilateral does not have to have any requirements as far as sides being the same or angles and stuff like this. Any four items, for example, or four sides. As long as it's closed. For example, this could be a quadrilateral here. Well, it could be, it is a quadrilateral. Okay. And none of the sides are parallel, nothing to do with the angles in there. One property that we'll use, though, is that the angles do add up to 360. There's no requirement that any two angles are the same, or anything like this. Now, all of the examples below are quadrilaterals, below this line, all of those. And if you can classify something more specifically, you need to do that. Now, the easiest one to see here is the kite. You see that this, okay, you see that these two sides are the same, these two sides are the same length. It'll also happen that this angle will be the same as this angle, and the intersection is 90 degrees. Okay, now I'm going to talk about trapezoids briefly here on the right-hand side. Trapezoid, just think of it as a triangle with the top cut off. That has to be cut off though so that it's parallel to the base of the triangle. So that's parallel to this side. That's the only requirement, a pair of parallel lines. But if you had a right triangle, it shouldn't be surprising that you would call this a right trapezoid when you cut off the top parallel to the base. Isosceles trapezoid, well, if you had an isosceles, oh, this board, try this again here. If you had an isosceles triangle, cut it off, parallel up, parallel, anyways, I won't draw for a minute. Then you've got an isosceles trapezoid. Just like isosceles triangles, two sides are the same. Isosceles parallel or trapezoids also have two sides the same. Going over to the other side here. Parallelograms. You have two pairs of parallel sides. So the left and the right are parallel here, and the top and the bottom are parallel. If you have a parallelogram, though, where the corner, at least one corner is 90 degrees, then the others are 90 degrees. We call that a rectangle. So two sides the same and all angles 90 degrees. Two pairs of same sides. Once you have all four sides the same, the more specific name for a rectangle with four sides the same is a square. Now you're familiar with that. If you kind of like imagine squishing the square, pushing it over sideways a little bit, you've got a rhombus, and a rhombus is like a square that's just tilted off to the side a little bit. Okay, enough of those. Whenever you're asked to classify something, you could always say everything's a quadrilateral, but I won't give you marks for that if you can be more specific. Okay, so be as specific as possible. Now some examples. So from this, okay, what type of quadrilateral is A, B, C, D? I'm going to do that portion of the question first. Remember that I said, think of these as triangles with the tops cut off. This was, what is it? Isosceles triangle with the top cut off. So we're going to call this an isosceles trapezoid. Once you know that, isosceles trapezoid, that means This side's the same as that side. So the first question, find AC. Well, AC will be equal to 4 centimeters. Okay. Angle A and angle B. There's a little bit of figuring to do there. Because it's isosceles, though, we do know that angle A is the same as angle B. So I'm going to write that down. Angle A is the same as angle B. And for figuring reasons, let's just call it X. Now, one thing we should remember about quadrilaterals is all the sides add up to 360. All the sides, my mistake, all the angles add up to 360. So if we know that, we know that 360, I get so distracted with this. I'll get back to it. 360 degrees is the sum of the 60 plus the 60. Let's call each of these little angles here X, just because they're A and B. We've got two groups of X then. Oh, 2X. My pen's misbehaving a little bit. Now if I add on the right hand side the 60 and 60, we get 120. I subtract it onto the left side. So 360, subtracting the 120, we've got 240. That's equal to 2 times that angle A or B, 2X. I divide both sides by 2 and I got 120. Equals what I call X on the diagram. So returning to the other side. Angle A and angle B is equal to 120 degrees. Okay? Pause if you need to go over something. Now, it doesn't ask you what shape this is, but let's just write this down. It's a kite. All right, a kite. Now looking at this, finding WX. WX is this side. Since it's a kite, I know that the bottom two sides, 3 and 3, they're the same. I know that WX is the same as XY. So WX is equal to 2 centimeters. That's right here. Okay? What else? What is the sum of the angles? WXY. So WXY, this angle here, and YZW, that angle there. Well, it is a type of quadrilateral, so everything adds up to 360. By symmetry, if this is 101, this is also 101. So that's good to know. How do I know that, though? I told you earlier, but that doesn't... Think of it this way. These are similar triangles. They share a side on the left and the right triangle, but divided up like that. The triangle on the left has a 2 centimeter side, this has a 2 centimeter side. 3 centimeter side, this side's 3 centimeters. Therefore, their angles are also equal. So the 101 and the 101 are matching. So that's how I know angle XYZ is 101. I'm going to use that. So I'm going to say the sum of these two angles, so angle WXY, angle YZW, plus 101 and 101 added together, so 202 equals 360 degrees. Running into my diagram like that. So I subtract my 202, and I have angle. $360 minus 202 is 158. Good. Third page with an example on here. This one's a little trickier. If we take a look at this one, well, a few things here. We're given that this is 38 degrees. And, well, let's take a look at that. What does that mean? These are all parallel lines. It says here they run parallel to each other, diagonally as shown. Okay. If this is 38 degrees, doesn't it make sense that this will be 38 degrees? This will be 38 degrees. Well, so will angle 1, 38 degrees by parallel lines. We've got that angle 1 is equal to 38 degrees. This goes back to your Workplace 10 course, where we used some geometry stuff, did some geometry stuff. Now, likewise, 38 degrees, well, that's parallel to this. Here where the 2 is, I'm going to try to figure out 2, but let's just draw 2 down here. Oh, my board. I'm going to undo that. Going crazy on me. I'll draw 2 again. I'll try to. So if this line is 2 here for this angle that we're trying to figure out, and I knew, I said that this is 38 underneath the 2. I'll just put that in here. Let's see where it comes from. That's 38 degrees. Hope you recall that a straight line is 180. Oh, this is 180 degrees. Oh, 180 degrees from here to here. Here to here is 180 degrees. So we can use that fact to figure out angle 2. Angle 2 must be 180 degrees subtracting the 38 degrees. So angle 2, doing some arithmetic in my head, 142 degrees. Okay. Now it gets trickier. Looking at angle 3 and 4. To do angle 3 and 4, I'm maybe going to extend some lines here just to see things clearer. So I'm going to pretend that I'm extending this line here. I'm going to extend this line here. Extend this line here. And I'm going to figure out angle 4 before 3, I think, just the way I drew it. You could do either one. Anyways, angle 4 before angle 3. If I take those lines here, I'm going to undo that there. So I've got to lock this page down so I can play with it. It's not locking for me, so there. Okay. Yep. I take this diagram here. Just copy it. I move. That's move it over here. I'm going to just do this so that I can see things clearer. So if I call this angle 4 right here. Okay. That's all I know right now. I do know, though, that this is a rectangle. Okay, a rectangular window, it says right at the start. So that means that this corner here is 90 degrees. All right? That could be useful. Think of this. From parallel lines, we knew angle 1 was 38 degrees. So if I run this up, the transversal, if you recall those things, doesn't it make sense? This angle up here is also 38 degrees. I'm going to put that on my diagram. 38 degrees right there. Okay, now opposite angles. That means this angle above the 4 would be 38 degrees as well. So coming back to figuring out angle 4, I'm going to just do the work over here on the left here. Angle 4 is going to be, well, we know that the full corner is 90 degrees at the corner of the rectangle. And we already know that write that down, 90 degrees. And we're going to take off the 38 degrees from the smaller angle. That means angle 4 must be 90 minus 38, 52 degrees. Okay. Angle 3 then. Angle 3 is this one. Now, you may remember some rules and stuff like this. How about this one though? We'll pretend that this is, well, pretend, it doesn't pretend. I'm going to consider this trapezoid here. All the angles will add up to 360. So one way of doing this is saying that angle 3 is equal to 360, because that's all the angles. Subtracting, I'm going to work down with my subtraction just because of limited on space. Angle 1, 38 degrees from the inside there. 142 degrees for angle 2. Minus what we just figured out, angle 4, 52 degrees. My pen isn't working, so I have to things are coming off. Okay, when I do all the subtraction, well, let's see what it is. Somehow my head isn't working. Oh gosh. Let me pause something for a second here. I gotta talk to someone. Okay, I'm back. If you did the subtraction, I was distracted by somebody else there. Where was I? Yeah, if you did this subtraction, 360 minus 38 minus 142 minus 52, you get 142. Likewise, you might have remembered some things too, that these two angles must add up to 180. You could have done it that way, subtracting 180 minus 38. There's a number of other ways you could have come up with things. You could have also thought about angle 4 will be the same underneath here, and that, you could use then the 180 minus the 52 that way. There's more than one way to figure that out, 142 though. Okay, try the problems, work away,